internet. Okay, so wake up at 2 to some very loud noises, which upsets me because that at least puts off my Thursday to a bad start. So I'm gonna try and turn it around, but it's not looking too good. At 6:30, I had a PT session at ROTC, which I slept through. I woke up at 8:10, realized that it was 8:10, got dressed very quickly, and ran over to the basement of the physical science building where my lab is scheduled for 8:30. There's a sign that says there are no labs this week. My voice just cracked. So now I have nothing to do until my regular physics class, I can't talk today, at 10:30. The main problem with that is that the 2-hour block that I set aside for the class is pretty much, I wouldn't say useless because I can do stuff. The actual going to do stuff and then making it back to the class on time is definitely throwing me for a loop. So I'm on my way to get some breakfast because I haven't eaten yet because I woke up 20 minutes ago. And I will see you, I won't see you ever, really. It's kind of sad.
Your time in remembering, and if you use them a couple of times, you will remember them. So, the idea here is, I don't like telling you to memorize a lot of stuff, but you do need to know these. So at the very least, have them on your reference sheet. These tell you, for instance, as time passes, where is an object located? So, the final location in the x direction of an object is influenced by where it began, how its initial velocity changed its position, and how its acceleration in that particular direction changes the position of this object with respect to time. Keep in mind, this is a 2 or a z?
2.
2, right? Okay, so it's a 2. Likewise, we have another relationship that says, the velocity of an object can change, so the final velocity of an object in the x direction is influenced by its initial velocity in that direction, and how the acceleration in that direction changes the velocity with time. The first equation says, what is the position as a function of time? The second equation says, what is the velocity as a function of time? Okay, fine. If you're a thinking type OSU cowboy, you might say, look, this first equation has t in it, so does the second. If I rearrange the second equation for time, shoehorned it back in here and was willing to do the algebra, I might be able to eliminate time. If you, in a moment of boredom, pursue this, you'll come up with what I call the drag racer equation. The drag racer equation says the final velocity that you have in the x direction squared is going to be given by the initial velocity in that direction, squared. Of course, it should be influenced, your final velocity in that direction should be influenced by your initial velocity, as well as how you accelerate in that direction through some displacement in that direction. And I think it's obvious why I'd call this the drag racer equation, because in drag racing, the name of the game is, you get in the car, you romp on the accelerator, funny name, and deliberately funny name, right? It is causing you to accelerate. Anyway, you romp on this thing, and you're trying to, in a fixed distance, let's say a quarter mile, go as fast as possible. So, you are accelerating through a fixed distance in an effort to change your velocity as much as you can. Now, these 3 forms are really Chapter 2. The description of